Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Imagine a world where all motion softens into silence, where every trembling atom and every restless particle finally comes to rest. This is the dreamlike vision scientists hold when they speak of absolute zero, the coldest temperature that nature allows, the perfect pause at negative 459.67 degrees Fahrenheit, or 0 Kelvin. It is not a place one can simply step into, nor a winter that one can wander through. It is a limit, a horizon of stillness, an idea that tugs at the very threads of physics and whispers about the deepest quiet the universe can offer. To imagine absolute zero is to imagine what happens when time itself seems to lose its rhythm inside the dance of matter. Every piece of matter in the universe, from the faintest dust to the strongest steel, is built of atoms. These atoms are never truly still. They quiver, they spin, they sway in invisible rhythms, humming softly with the song of thermal energy. This humming is what we call temperature. The higher the temperature, the more urgently the atoms move, colliding and tumbling in a restless dance. When we lower the temperature, the dance slows, the steps soften, the collisions grow gentler. The thought of absolute zero is the thought of what might occur if that dance could one day come to an end. But science reminds us gently, we can approach absolute zero and never fully arrive. It's like chasing the horizon. You may walk closer and closer, but the edge will keep slipping further away. Absolute zero is an asymptote, a limit drawn by the laws of physics. The closer we draw to it, the more energy and precision it requires, until it becomes an endless task. Yet this endless pursuit has not discouraged scientists. Instead, it has deepened our curiosity. For as we move toward this unreachable stillness, remarkable things happen. Strange states of matter bloom, and the ordinary rules of the world begin to bend like light passing through a prism. In the 19th century, explorers of cold like Lord Kelvin wondered what mysteries would unfold near this frozen edge. They measured gases, observing how their pressure sank lower and lower as the air cooled. These experiments revealed patterns so delicate they suggested a point where motion would finally cease. This became the birth of the absolute scale of temperature, the Kelvin scale, a ladder that begins not with the freezing of water, but with the stillness of atoms. On this ladder, zero is not a beginning of ice, but the imagined end of all motion. Think of atoms as tiny instruments in an orchestra. At high heat, the music is frantic, a wild symphony of vibrations. As the temperature falls, the music slows into a lullaby. Near absolute zero, the instruments whisper in barely audible tones, their strings trembling so lightly they almost seem to rest. Yet quantum mechanics, the science of the very small, tells us that they can never truly fall silent. There is always a ghostly remainder of motion, what physicists call zero-point energy. Even at absolute zero, atoms keep the faintest trace of their inner hum, like the echo of a song long after it has ended. This quantum hum is not a flaw in nature's design, it is the fabric of existence itself. If every atom were truly frozen without motion, if every vibration faded to nothing, the rules of physics would collapse, and the world would unravel. The zero-point energy is a safeguard, a gentle reminder that silence is never absolute. that even in the deepest cold there is always a hidden rhythm keeping the universe alive. So when we speak of absolute zero, we speak not of absolute stillness, but of the closest approach to it, a horizon that forever glimmers just out of reach. In laboratories around the world, scientists have built machines that chase this dream. They use lasers that can slow atoms like invisible hands, catching them in webs of light. They use magnetic traps that hold matter still in the gentlest of cages. With these tools, they have cooled gases to billionths of a degree above absolute zero. At these delicate temperatures, strange and beautiful states of matter appear. One such state is the Bose-Einstein condensate, where countless atoms lose their individuality and merge into a single quantum wave, moving as if they were one vast particle. In these condensates, atoms seem to forget their separateness, blending into a single voice that hums softly in unison. Imagine standing in a quiet forest at night. The air is so still you can hear the faint rustle of each leaf. Then, in the deeper silence, you notice that the trees are no longer separate voices, but a single breath moving through them all. That is what happens inside a Bose-Einstein condensate. The many become one. The scattered orchestra becomes a single instrument playing one pure note. It is a glimpse of unity born from coldness, a harmony that can only be reached in the shadows of absolute zero. The pursuit of these frozen frontiers teaches us more than physics. It teaches us patience, delicacy, and reverence for the fragile. To cool something so close to absolute zero, every vibration, every stray photon of light, every tremor of heat must be controlled. It is like trying to quiet a vast crowd until all you hear is the breath of one sleeping child. The effort reveals how interconnected everything is, how even the faintest ripple of energy can disturb the balance. It is a reminder that the universe is built upon layers of subtlety, and that sometimes the most extraordinary truths hide in the gentlest silences. Even the stars remind us of this cold frontier. Space between galaxies drifts at just a few degrees above absolute zero. The cosmic microwave background, the faint afterglow of the Big Bang, fills the universe with a soft blanket of nearly frozen radiation. It is as if the cosmos itself carries a memory of the cold, wrapping everything in a reminder of its origins. To gaze upon the night sky is to gaze upon a universe always leaning towards stillness, always reaching for that perfect hush that lies at the end of the temperature scale. And so, absolute zero is both a destination and a metaphor. It is the limit of cold, but also the dream of perfect rest. It is the longing for a moment when every restless motion finds peace. Scientists may never touch it directly, but they approach it like pilgrims, knowing that each step closer reveals not emptiness but wonder. For in this pursuit, we glimpse the strange truth that the closer we come to silence, the more the universe begins to sing in new and unexpected ways. The stillness beneath all motion is not an ending, but a hidden beginning. It is the place where atoms begin to weave themselves into patterns we cannot see in warmth. It is the quiet chamber where quantum worlds open their doors. It is not the silence of nothingness, but the silence of potential waiting to be understood. To rest in this thought is to feel a deep calm, to know that even the coldest horizon is filled with mystery, and that beneath every stillness lies a hum, a pulse, a life that never truly stops. Now let us drift deeper into the stillness, moving beyond the first impressions of absolute zero and into the more delicate truths that bloom when matter cools toward that unreachable horizon. The story does not end with atoms slowing. In many ways, it begins anew. The closer we move to absolute zero, the more the world ceases to look familiar. Laws of physics that seemed solid begin to fold into gentler patterns. Everyday intuition softens, and quantum behavior emerges like hidden currents beneath a quiet sea. At ordinary temperatures, the motion of atoms is too fast and tangled to reveal much of their hidden nature. Each atom collides, scatters, and moves unpredictably. But as the temperature falls, their motions shrink, their energy becomes faint, and their hidden symmetries reveal themselves. Matter begins to show us that it is not merely a collection of particles, but a web of wave-like beings. Atoms are not only points of mass, but also ripples of probability, extending softly into the space around them. When cooled, these ripples overlap, and the individuality of each atom begins to blur into a larger whole. This blurring creates phenomena that defy the rules of the warm world. One such phenomenon is superfluidity. In liquid helium cooled near absolute zero, the atoms stop behaving like independent swimmers. Instead, they flow together with no resistance at all. A superfluid can climb the walls of its container, slip endlessly through tiny cracks, and swirl forever without slowing. It is water without friction, a dreamlike liquid that seems more spirit than matter. To see superfluid helium is to witness the impossible made calm, a substance that refuses to obey the ordinary limits of viscosity and drag. Equally wondrous is superconductivity, a state discovered in metals and ceramics near absolute zero. In this quiet state, electrons, the tiny charges that carry electricity, stop scattering against impurities and resistances. Instead, they form gentle pairs and glide together without loss. A superconducting wire can carry current endlessly, with no heat, no waste, no fading of energy. It is electricity purified into permanence. In laboratories, superconductors are used to create magnetic fields so powerful they can lift trains above their rails, allowing them to glide with a silence that seems otherworldly. These are not dreams, but realities born from the pursuit of cold. Why do such marvels only appear near absolute zero? The answer lies in the way temperature governs disorder. Heat is chaos, a trembling that masks subtle order. When heat is removed, the chaos ebbs and hidden harmonies emerge. Absolute zero is not the erasure of life in matter, but the unveiling of its most refined states. It is the quiet stage on which atoms can perform their most graceful and collective dances. Without the masking noise of warmth, we glimpse the pure essence of physics, the delicate structures that underlie the noisy surface of the everyday world. Yet absolute zero is not only about exotic states of matter, it also reveals profound truths about time and entropy. Entropy, the tendency of systems to drift toward disorder, is bound to temperature. As something cools, its entropy falls, its randomness decreases. But as we approach absolute zero, entropy approaches a flaw, a limit described in the third law of thermodynamics. This law tells us that no finite number of steps can ever bring entropy to zero, just as no cooling method can ever reach absolute zero itself. Nature builds its barriers carefully, ensuring that stillness remains a horizon, not a destination. It is as if the universe always preserves a whisper of uncertainty, a reminder that perfection is not for us to hold. These laws shape the very fabric of existence. Consider the cosmic balance. Stars burn hot in their cores, scattering light and warmth into space, while the void between them chills toward absolute zero. The dance of creation and cooling, of heat flowing outward and the universe sinking into coldness, defines the passage of time itself. If the cosmos were ever to reach uniform stillness, time as we know it would dissolve. The arrow of time is drawn by the flow of heat, by the difference between warmth and cold. Absolute zero, then, is not merely a temperature. It is the imagined boundary of time's story. In the laboratory, when scientists cool atoms to billionths of a degree above absolute zero, they are not only exploring strange materials, they are touching the limits of meaning. They are probing the edge where the quantum world swallows the classical, where the small instructs the vast. Atoms aligned in a Bose-Einstein condensate show us the possibility of unity. Electrons paired in a superconductor show us the grace of cooperation. Helium flowing as a superfluid shows us the beauty of frictionless existence. These are lessons written in the cold, poems inscribed in silence. Think for a moment of how this pursuit mirrors our own human longing. We too seek stillness, quiet, release from the restless dance of thought. In the silence of meditation, in the calm of sleep, in the pause between breaths, we too approach our own versions of absolute zero. We never quite arrive, there is always a pulse, always a thought lingering. Yet the journey towards stillness is enough, for it reveals new states of being, new harmonies beneath the noise. The science of cold mirrors the inner search for peace, reminding us that stillness is never absolute, but always enough. Now let us return to the cosmic stage. Far beyond our world, galaxies spin and scatter their light. Between them stretches a darkness filled with faint whispers of ancient radiation. This cosmic microwave background is just 2.7 degrees above absolute zero, a relic of the Big Bang itself. It is the cold memory of creation still glowing after nearly 14 billion years. This faint warmth drifting through the universe is a reminder that the cosmos itself is always cooling, always moving toward the quiet edge of absolute zero, though it may never fully arrive. And so we see that absolute zero is not only a scientific idea but a cosmic metaphor. It is the unreachable center that guides our understanding of matter and time. It is the teacher that reveals hidden harmonies when heat is taken away. It is the reminder that even in the coldest silence, life persists in the hum of zero-point energy, in the quantum ripples that cannot be erased. The pursuit of absolute zero is the pursuit of beauty, patience, and humility. It is a journey without an ending, but with endless revelations along the way. To imagine absolute zero is to imagine the quiet heart of the universe. It is to picture atoms flowing in unity, electrons gliding without resistance, and liquids climbing silently against gravity. It is to hold in our minds the image of a cosmos where motion softens into whispers, where time itself pauses at the brink. And in this imagining we find not despair at an unattainable goal, but wonder at the journey itself. For sometimes what matters most is not the silence we reach, but the harmony we discover on the way. Let us drift now into the closing part of this story, where all the threads of absolute zero gather into a gentle resolution. We have walked through the slowing dance of atoms, the blooming of strange new states, and the cosmic silence that embraces all things. Now we pause at the edge, letting the idea of perfect stillness unfold as a reflection, not only of physics, but of existence itself. for absolute zero is more than a number. It is a symbol, a horizon of thought, a quiet meditation woven into the very structure of the universe. Imagine holding a handful of air on a summer day. Each molecule moves frantically, colliding, bouncing, rushing about in ways we cannot see. Lower the temperature, and the molecules slow, moving with less urgency, as if pausing for breath. Lower it further, and the gas becomes a liquid, molecules huddled together, trembling faintly in their bonds. Lower it still more, and the liquid becomes a solid, the atoms locked into crystalline patterns, each vibrating madly in its cage. And then imagine lowering the temperature still further into realms where the vibrations weaken almost to silence. This is the journey toward absolute zero, a journey through the seas of matter, ending not in emptiness, but in a whisper of motion that never disappears. Quantum mechanics insists on this whisper. Even in the coldest crystalline lattice, atoms quiver faintly with zero-point energy. This lingering hum cannot be stripped away, for it is part of what makes the atom itself possible. Without it, electrons would collapse into their nuclei, matter would unravel, and the universe would cease to exist. Absolute stillness is forbidden, not as punishment, but as protection. The tiny tremors of zero-point motion are the heartbeat of matter, a secret rhythm that ensures creation continues. This truth is both scientific and poetic, that beneath the silence there is always a pulse, no matter how faint. To study absolute zero is therefore to study the boundary between presence and absence, between motion and stillness, between time and timelessness. Time is tied to change. It flows because atoms move, because heat travels, because differences fade. If there were a place where nothing moved, where no change occurred, time itself would lose its meaning. Absolute zero is not only the end of temperature, it is the imagined end of time's arrow. And yet, because we can never truly reach it, time continues, carried forward by the smallest tremors, the faintest quivers that prevent the universe from falling asleep forever. This impossibility teaches humility. Science, for all its precision, is full of horizons that cannot be crossed. The speed of light, the uncertainty principle, the singularities inside black holes, all are boundaries that define not only what we cannot do, but what reality itself cannot allow. Absolute zero joins them, standing as a reminder that limits are as much a part of nature's poetry as possibilities. To approach the limit is to glimpse its lessons. To imagine crossing it is to dream. But to accept that it will never be reached is to honor the mystery that keeps the universe alive. In human terms, this pursuit mirrors our longing for rest. We tire, we yearn for stillness, we close our eyes at night hoping for the quiet of sleep. Yet even in sleep the heart beats, the lungs fill, the neurons flicker in dreams. We never reach absolute stillness, nor would we want it to, for it is the pulse that makes us human, the rhythm that keeps us alive. Our own lives echo the physics of atoms. We can approach rest, but never erase movement entirely, and perhaps this is a gift. Perhaps perfection is not in silence, but in the harmony between silence and sound, between stillness and motion. Consider again the universe itself cooling slowly over billions of years. The stars that now blaze will one day fade. The galaxies will drift farther apart, and the cosmic background will sink closer to zero. Some scientists imagine a distant future where the cosmos lies in near-perfect stillness, with black holes evaporated, stars extinguished, and matter spread thin across vast darkness. This heat death of the universe is the ultimate vision of cooling, a universe forever poised just above absolute zero, quiet and endless. It is a sobering thought, but also a serene one, for in that stillness there is no struggle, no conflict, only the soft hush of eternity. Yet even this vision is not complete silence. Quantum mechanics tells us there will always be fluctuations, particles flickering in and out of existence, ripples of vacuum energy threading through space. The universe will never truly sleep. It will always hum faintly with its own quiet song. Absolute zero, then, is not death, but the deepest breath of life, the lowest note in the symphony of existence. And to know this is to rest more easily, understanding that silence is never empty, but always full of unseen music. So let us close gently, returning to the image of atoms as an orchestra. At high temperatures, the orchestra plays wildly, each instrument clashing in chaotic symphony. As the world cools, the music slows, softens, and harmonizes. Near absolute zero, the orchestra breathes as one, the instruments blending into a single note that hovers almost beyond hearing. And though we can never silence it completely, the song is enough, delicate and eternal. For in that faint note lies the story of matter, of life, and of the universe itself. Absolute zero is not the absence of motion, but the perfection of balance. It is the stillness beneath all motion, the horizon that shapes time and meaning. It is unreachable, and yet it guides us, like a star we can never touch but always follow. And in that following, in that endless approach, we discover more than silence. We discover beauty. We discover wonder. We discover that even at the edge of stillness, the universe continues to sing. The frozen heart of the universe is not a place you can journey to with ships or maps. It is not a single corner of the cosmos where ice gathers in silence. Instead, it is everywhere and nowhere, hidden in the faint cold between stars, in the whispering chill that lingers across billions of miles. When you look up at the night sky, the starlight dazzles, but between those stars lies an ocean of darkness, and that darkness is cold beyond imagination. It is here, in this endless quiet, that the universe reveals its frozen heart, beating softly at just a few degrees above absolute zero. From the warmth of our Earth, where life thrives and oceans flow, it is hard to picture such coldness. Yet most of the universe does not shine. Most of the cosmos is dark, silent and frigid, stretching far beyond the warmth of suns. Between galaxies, the temperature rests at around 2.7 Kelvin, just above absolute zero. This faint coldness is not emptiness, but the afterglow of creation. It is the cosmic microwave background, the oldest light in existence, left behind from the moment the universe was born. This faint radiation is the frozen memory of the Big Bang, stretched thin as space itself expanded, cooling into a soft, invisible blanket that fills the entire cosmos. To imagine the cosmic microwave background, close your eyes and picture the warmth of a fire fading in a vast room. At first, the flames blaze, heat rushing outward, filling every corner. Over time, the fire dies, the heat spreads, and the room grows cool. Now stretch that idea across billions of years, across the entire universe, and you begin to feel the meaning of that background glow. It is the last warmth of a cosmic fire that once burned with unimaginable brilliance, now softened into a chill that whispers through the void. Scientists discovered this background not by seeking it, but by accident. In 1964, two engineers, Arno Penzias and Robert Wilson, were tuning a radio antenna in New Jersey. No matter what they tried, their instrument hummed with a faint static they could not remove. They cleaned the antenna, adjusted its parts, and even cleared away nesting pigeons. Yet the static remained. It was, as they later learned, the very whisper of the universe itself, the cosmic microwave background, the frozen heartbeat of creation humming softly in all directions. In that discovery, the frozen heart of the cosmos revealed itself to human ears, reminding us that even silence carries memory. This background radiation is astonishing not only for its existence, but for its uniformity. It glows almost the same in every direction, with only the faintest ripples of variation. These tiny ripples, less than 1,000th of a degree, are the seeds of all the galaxies we see today. From them, matter gathered, stars ignited, and worlds were born. In the frozen heart of the universe there is not only silence, but the faint echo of beginnings. It is as though the universe itself remembers its first breath, and keeps that breath alive in the faintest glow of cold light. The frozen heart also lies within the life cycles of stars. When a star like our Sun exhausts its fuel, it cools, shrinks, and drifts into darkness. These remnants, called white dwarfs, are still warm at first, glowing with residual heat. But over billions of years, they will radiate away their last warmth and become black dwarfs, dark, frozen husks of stars resting near absolute zero. None exist yet, for the universe is not old enough. But one day countless black dwarfs will populate the galaxy, each a silent reminder of light that once was. These will be the frozen embers of starlight, the quiet cinders of creation waiting in the endless dark. Beyond stars and galaxies, black holes also hold a place in the frozen heart of the cosmos. Though they are often thought of as fiery monsters, swallowing matter and light, black holes are deeply tied to coldness. They radiate faintly through what is called Hawking radiation, a slow release of energy that causes them to shrink over unimaginable spans of time. Eventually, even black holes may evaporate, leaving behind only a faint whisper of energy. What remains will be emptiness close to absolute zero, the universe's coldest memory. In this way, the frozen heart does not simply belong to the spaces between stars, it belongs to the destiny of all things. And yet the frozen heart is not lifeless. In the coldest places, in molecular clouds drifting through galaxies, stars are born. These vast nurseries of dust and gas rest at just a few tens of degrees above absolute zero. Their chill allows gravity to work its quiet art, pulling matter together until the weight ignites fusion and a star is born. Out of frozen silence, light returns. In the frozen heart of the universe, creation and stillness are not enemies but partners. Cold gathers matter into seeds. Heat bursts those seeds into shining suns. Without the frozen heart, there would be no galaxies, no stars, no us. The frozen heart also connects to our own world. Deep under Antarctic ice at temperatures near absolute zero, scientists have built instruments to catch neutrinos, ghostly particles that pass through matter without pause. These particles carry messages from the most violent events in the cosmos: exploding stars, colliding black holes, distant galaxies. And yet, to detect them, We rely on the stillness of ice, on the frozen silence of our own planet. Even here on Earth, the frozen heart of the universe speaks, whispering through the smallest signals, reminding us that the story of cold stretches from the cosmic scale to the human one. As we reflect on this, the frozen heart becomes not just a scientific truth, but a metaphor for patience and endurance. Cold is not the absence of life, it is the stage on which new forms of life emerge. Cold preserves, protects, and holds memory. The frozen heart of the universe is the keeper of beginnings, the quiet ground from which all stories rise. It teaches us that silence can be fertile, that stillness can contain possibility, and that even at the edge of nothingness, creation stirs. So when we speak of the frozen heart of the universe, we speak of the cosmic background glow, of the cold spaces between stars, of the future fate of galaxies, and of the icy nurseries where stars awaken. But more deeply, we speak of a truth that flows through science and poetry alike, that in silence lies memory, and in stillness lies birth. The frozen heart is the pulse of the cosmos slowed to its quietest rhythm, the faint breath of a universe that carries its own beginnings in the soft hush of cold. Let us journey deeper into the frozen heart of the universe, where silence and cold are not merely backgrounds, but sculptors of cosmic form. We begin by imagining the great voids between galaxies, those vast stretches of space where light seldom travels, where matter is sparse, and where temperature sinks close to absolute zero. These regions, colder than any desert night on Earth, remind us that most of the universe is not warm with starlight, but cold with emptiness. Yet even emptiness is never truly empty. Within it lie faint photons from the Big Bang, drifting endlessly, the frozen heartbeat of creation stretched across space and time. The cosmic microwave background is the canvas of this frozen heart. Its uniform chill tells us that the universe once was fire, a plasma glowing brighter than any star, so dense and hot that atoms themselves could not exist. As the cosmos expanded, that fire cooled, and the plasma thinned until atoms formed and light escaped. That light, stretched by the swelling of space, softened into microwaves, filling every corner of the universe with the temperature just above absolute zero. What we see today is not the fire itself, but its memory, written in coldness. The frozen heart is not the absence of warmth, but the persistence of history carried in silence. Scientists have studied this background with exquisite precision, mapping its faint ripples with satellites like COBE, WMAP, and Planck. These ripples are the fingerprints of the earliest structures in the universe, tiny fluctuations in density that grew into galaxies and clusters. Without the frozen calm of the cosmic background, we would not know how the cosmos began, nor how it grew. The heart of the universe is not frozen in ignorance but in memory, holding the traces of beginnings like fossils in ice. To study it is to listen to the first lullabies of time itself, carried across the darkness on waves of invisible light. Beyond this radiation, the frozen heart reveals itself in the silence of interstellar clouds. These are places where dust and molecules rest in stillness, at only a few dozen degrees above absolute zero. Within them, chemistry writes the alphabet of life. Complex organic molecules form in the quiet cold shielded from the destructive heat of stars. When a star is born in these clouds, it warms the molecules and scatters them across space, planting the seeds of biology in future worlds. Thus, the frozen heart is not only memory but Gould, womb, where the building blocks of life are assembled in delicate silence. One of the most extraordinary examples of cold creation is found in the icy moons of our solar system. Europa, Enceladus, and Titan all carry frozen surfaces, their shells resting near absolute zero in the shadow of distant suns. Beneath their frozen crusts, however, lie oceans of liquid water, warmed faintly by tidal forces and hidden geothermal energy. In the frozen silence above, there may be life stirring below. These worlds remind us that cold is not an enemy to life but a protector. It preserves, shelters, and guards the potential for emergence. The frozen heart of the universe is not lifeless. It is a cradle wrapped in ice. Cold also governs the destinies of stars. White dwarfs, the remnants of ordinary suns, will cool endlessly, radiating their last warmth into the dark. Over billions of years they will fade into black dwarfs, frozen stars resting in near absolute zero. Though none exist yet, the universe is already preparing them, slowly cooling the glowing remnants that remain. In time, galaxies will be filled with such darkened embers, each a testament to light that once burned. These frozen relics will be the archives of starlight, preserving in silence the history of energy once spent. And yet, even colder fates await. The idea of heat death tells us that as the universe expands, stars will fade, black holes will evaporate, and matter itself will stretch thinner and thinner until all lies near absolute zero. This vision is not a fiery end, but a gentle fading, a cosmic lullaby descending into stillness. It is the frozen heart extended across eternity, the universe sighing into quiet after its long, bright song. Though it seems solemn, there is peace in this image, for in the silence of cold lies the end of struggle, and in the frozen heart lies the memory of all that came before. Quantum mechanics adds another layer of wonder. Even in the coldest darkness, particles flicker into existence and fade again, a restless dance that never entirely stops. The frozen heart is never empty. It is threaded with zero-point energy, the faint hum of the quantum vacuum. This hum ensures that the universe, even at its quietest, is never silent. It is the final paradox of cold, that the closer we come to stillness, the more subtle rhythms emerge. Atoms, particles, and fields continue their ghostly dance, reminding us that the frozen heart is alive with invisible music. For us, standing on our small world, the frozen heart may feel distant, yet its lessons reach into our lives. Cold preserves the past, whether in ice cores that record Earth's climate, or in fossils kept pristine under glaciers. Cold gives birth to new, whether in the interstellar clouds that form molecules, or in the hidden oceans that may harbour life. Cold humbles us, reminding us of the limits of heat, time, and energy. To reflect on the frozen heart is to remember that silence and stillness are not voids, but spaces of potential memory and creation. The frozen heart of the universe is not simply the absence of heat. It is the quiet keeper of beginnings and endings, of fire turned to ash, of chaos turned to harmony. It is the silence that lets us hear the faintest echoes of creation. It is the stillness that allows stars to form, life to grow, and history to endure. In the depths of space, in the chill between galaxies, In the fate of dying stars, the frozen heart beats softly, eternal in its patience. To imagine it is to feel the calm of infinity, to hear the universe breathing slowly, to know that beneath all warmth and brightness lies a gentle, enduring cold that holds the cosmos together. Now we arrive at the closing reflection of the frozen heart of the universe, where the story of coldness turns into poetry about time, destiny, and the quiet persistence of memory. We've wandered through the cosmic microwave background, through clouds of molecules, through dying stars and icy moons. Each step has shown us that cold is not the absence of life, but the stillness that shapes it. In this final part, let us rest in the silence itself and see what meaning it offers. Imagine the universe as a great symphony. In its beginning, the music was loud and blazing, a cosmic explosion of energy, heat, and light. Over billions of years, that music has slowed, softened, and cooled, each note stretching longer and quieter. Today, the universe still plays, but its notes are faint, wrapped in the chill of 2.7 Kelvin, the temperature of the cosmic microwave background. The frozen heart of the universe is the faint vibration of this last note, echoing through space like a lullaby played across eternity. This lullaby is not sorrowful. It carries no grief, but a gentle acceptance. Stars burn, then fade. Worlds form, then dissolve. Galaxies swirl, then scatter. Each event is part of the great cooling, the long sigh of creation as it releases its warmth into space. In the far future, that sigh will continue until only cold remains. Black dwarfs will rest in silence. Black holes will evaporate into faint whispers of energy. Matter will drift thin, nearly motionless, as the universe nears absolute zero. This is the vision of heat death, where all becomes still. But stillness is not nothingness. It is the last form of balance, a cosmic peace at the end of time. Even then, the frozen heart will never be perfectly still. Quantum fluctuations will ripple through the vacuum. Particles will flicker into existence and vanish again. The hum of zero-point energy will persist, like the faint pulse of a sleeper who never fully rests. The frozen heart will continue to beat, softly, invisibly, carrying forward the truth that silence is never complete. This hum is not noise but presence, a reminder that even in endings, the universe is never empty. The frozen heart also teaches us how small we are, and yet how deeply connected. Every breath we take, every spark in our neurons depends on the balance between warmth and cold. Our world exists in a narrow band of temperature, where water can flow, where life can grow. But beyond our fragile home, cold dominates. The universe is not made for us. It is made of vast stretches of frozen silence, and yet, within this silence, life found a way to sing. That is the paradox of the frozen heart. It is vast, indifferent, and cold, but it allowed warmth and life to blossom for a while here on Earth. To reflect on this is to feel humility. We are brief flames against the backdrop of eternal cold. Our civilizations burn bright for moments compared to the lifespan of stars, and yet we too will fade. But like the microwave background, perhaps something of us will linger. the frozen heart remembers everything. The glow of the Big Bang, the birth of galaxies, the seeds of life drifting across space. In its cadence, it holds the memory of all things. To become part of that silence is not loss. It is return, a merging with the universe's deep stillness. Coldness also teaches patience. The processes of the cosmos unfold over spans so long they defy imagination. Stars take millions of years to form. White dwarfs take billions to cool. Black holes take trillions to fade. The frozen heart of the universe is a slow story, one told not in minutes or centuries but in eons. To reflect on it is to slow ourselves, to remember that our hurried lives are but sparks in the endless night, and yet those sparks matter, for without them, the universe would be only cold silence. It is our warmth, our light, that adds music to the frozen heart, if only for a moment. And so the frozen heart is both destination and origin. It is the memory of the Big Bang still glowing softly in microwaves. It is the womb of stars, cradling matter in cold clouds until new suns ignite. It is the destiny of dying stars, cooling into black dwarfs. It is the far horizon of time, when galaxies fade and only silence remains. And it is here, now, in the spaces between stars, in the icy shadows of moons, in the faint static of the night sky. It is not distant. It surrounds us always. When you stand beneath the stars and feel the cool air of night, you are touching the frozen heart of the universe. The chill you feel is kin to the chill of cosmic space, to the cold between galaxies, to the silence that holds all things together. In that moment, you are part of the same story. The warmth in your breath, the fire in your cells, the spark of your thoughts, all of it shines briefly against the frozen background, like starlight shining against the dark. And just as starlight is remembered in the silence of space, perhaps your warmth too will linger in the memory of the cosmos. Let us close with this thought. The frozen heart of the universe is not an ending to be feared, but a mystery to be embraced. It is the balance beneath all heat, the silence beneath all sound, the patience beneath all change. It is unreachable and yet always present, surrounding us, reminding us that every warmth we know is precious against the backdrop of eternity. To rest in that knowledge is to feel peace, to let go of urgency, and to hear the faint hum of the universe itself, singing softly in the frozen dark. There is a place in science where silence and wonder meet, a boundary where cold approaches its deepest form. We might call it the edge of cold, the region just above absolute zero, where atoms no longer rush about like restless dancers, but slow into whispers, faint and delicate. At this edge, matter reveals its most secret behaviours hidden by the noise of heat in our everyday world. It is here, in the almost absolute cold, that the universe whispers its quietest truths, waiting for us to listen. To imagine the edge of cold, think of a forest at night. The wind is stilled, the leaves hang motionless, and the air feels heavy with silence. Yet in that silence you notice the smallest sounds, the rustle of a mouse, the faint hum of an insect, the breath of your own lungs. In the same way, when atoms are cooled to the edge of cold, the faintest aspects of their quantum nature emerge. No longer drowned out by the roaring motion of heat, the hidden symmetries and rhythms of matter begin to reveal themselves like whispers in the stillness. For centuries, scientists wondered what might happen If matter could be cooled near absolute zero, would atoms stop altogether? Would time itself lose meaning? It was only in the 20th century that new physics gave an answer. The quantum world, it turned out, refuses to be silent. Even at the edge of cold, particles retain a ghostly shimmer of energy, a hum that cannot be erased. This hum is not noise but foundation, a reminder that existence itself is woven from subtle vibrations. And so the whispers at the edge of cold are not the end of motion, but its most delicate form. One of the most remarkable discoveries of this realm is the Bose-Einstein condensate. Predicted by Satyendranath Bose and Albert Einstein in the 1920s, it remained a dream for decades, too fragile to achieve with the technology of the time. Only in 1995 did scientists first create it, cooling rubidium atoms to billionths of a degree above absolute zero. What they found was astonishing. The atoms lost their individuality, merging into a single quantum wave, behaving not as many, but as one. At the edge of cold, the boundaries between particles dissolve and matter whispers in unison. This merging is unlike anything in the warm world. Normally, each atom carries its own identity, colliding, scattering, and moving freely. But in a Bose-Einstein condensate, they overlap and blur into a single state, a collective presence that flows without resistance. It is as if 1,000 voices in a crowd suddenly chose to sing the same note, so perfectly aligned that no one voice can be distinguished from another. This unity, born only at the edge of cold, is a glimpse into the deeper harmony of nature, hidden beneath the noise of heat. Another whisper of the edge of cold is found in superfluidity. In liquid helium cooled near absolute zero, something magical happens. The liquid stops behaving like ordinary matter. It flows without viscosity, without friction, slipping endlessly through cracks and climbing the sides of its container. Imagine water that could climb upward like ivy, that could swirl forever without slowing, that could defy the ordinary laws of drag and resistance. Liquid exists, but only in the frozen silence of the edge of cold. It is as though the liquid itself has become a whisper, too subtle for friction to grasp. Superconductivity is another song of this realm. When certain materials are cooled close to absolute zero, their electrons form pairs and flow without resistance. Electricity, normally plagued by waste and heat, comes pure and eternal. A current can circle in a superconducting loop forever, without losing energy. Magnets levitate above superconductors, gliding as if freed from gravity's pull. These effects are not only practical marvels, they are poetic whispers of matter's hidden grace, revealed only when the world grows cold enough to listen. The whispers at the edge of cold are not confined to laboratories. They are part of the cosmos itself. In interstellar space, vast clouds of dust and gas rest at just a few degrees above absolute zero. Within their cold silence, chemistry unfolds. Molecules combine, complex structures form, and the seeds of life are sown. In this chill, gravity begins its slow work, pulling the clouds together until stars ignite. Thus, the edge of cold is both womb and cradle, the place where stillness gathers strength to create brilliance. Out of silence comes song. Out of frozen whispers comes fire. To stand at the edge of cold is to glimpse the delicate balance between silence and sound, between stillness and motion. The ordinary world hides these truths beneath the noise of heat, but cooling strips away the veil. allowing us to see matter in its most essential form. It is like hearing the faint strings of a harp beneath the roar of an orchestra, realizing that the music was always there, waiting for quiet to be heard. The whispers at the edge of cold are reminders that silence is not emptiness, but the doorway to deeper understanding. And so we return to the image of atoms as voices. At high temperatures, they chatter loudly, each speaking at once in confusion. As the temperature falls, the chatter softens into murmurs. Near absolute zero, the voices align, merging into one whisper that carries the essence of their being. It is this whisper that reveals the beauty of Bose-Einstein condensates, the magic of superfluidity, the grace of superconductivity. Each is a verse in the quiet song of the edge of cold, a song too subtle to be heard until the world is stilled. To reflect on this edge is to recognize the value of silence in our own lives. Just as matter reveals its hidden harmonies when cooled, so too do we discover hidden truths in our moments of stillness. In the quiet between breaths, in the pause of thought, in the calm of rest, we too hear whispers of memory, of meaning, of connection. The whispers at the edge of cold are not only physical but metaphorical, teaching us that stillness is fertile and that quiet is alive with hidden voices. The edge of cold is not a destination but a threshold. It is the place where matter ceases to behave as it does in warmth and begins to reveal the deeper rules of existence. It is the twilight between motion and stillness, the liminal space where whispers take the place of shouts. And in those whispers, the universe tells us secrets about unity, about harmony, about the hidden life of atoms. To listen is to learn, and to learn is to be humbled, reminded that the quietest corners of nature are often the most profound. Let us drift deeper into the edge of cold, where whispers of matter become clearer, and where the strange beauty of physics takes on its most delicate forms. The journey into this realm is not merely scientific, it is poetic, filled with images of unity and transformation. To cool atoms close to absolute zero is to strip away layers of noise, revealing the soft patterns that lie beneath. At this threshold, matter no longer obeys the rules we know from daily life. Instead, it folds itself into quantum harmonies, weaving a song that can only be heard in stillness. Consider again the Bose-Einstein condensate, that extraordinary state of matter where individuality dissolves. To understand its wonder, imagine a room filled with dancers. In the warmth of ordinary life, each dancer moves in their own rhythm, colliding, spinning, and scattering with little coordination. But as the room cools, the dancers slow, their movements aligning. Finally, at the edge of cold, they merge into a single dance, their steps indistinguishable, their presence united. This is the condensate. Not many, but one, not noise, but harmony. It is a reminder that beneath all separateness there lies the possibility of unity, revealed only in silence. Superfluidity adds another whisper to this chorus. When helium becomes superfluid, it defies friction, flowing endlessly, climbing walls, creeping in ways that feel more like spirit than liquid. If you pour superfluid helium into a container, it will not stay. It will spread, flowing thinly up and over the edges, seeking every space it can fill. It refuses confinement, moving with a grace that ignores ordinary limits. This behavior feels like a metaphor for freedom, for the refusal to be bound by resistance, and yet it is born not in fire or force, but in cold, in the stillness that allows the atoms to flow as one. Superconductivity too is a whisper of grace. Electricity in its ordinary form is full of waste. As electrons travel through wires, they collide with imperfections, releasing heat, losing energy. But near the edge of cold, the electrons form pairs, moving together in perfect coordination. They glide without scattering, without loss, without waste. Imagine a river that never slows, a current that never fades. This is superconductivity, the purest form of electricity, revealed only in the frozen silence. It is a promise of efficiency, a dream of endless flow, hidden within the whispers of cold. The edge of cold also reveals truths about light itself. In Bose-Einstein condensates, not only atoms but photons, the particles of light, can merge into a single quantum state. Light, normally swift and free, becomes heavy and still, trapped in delicate patterns of matter. In this frozen dance, photons move as one, their individuality erased. It is as though light itself has paused to whisper, slowing enough to show us its deeper nature. This merging of light and matter is one of the most profound whispers of the edge of cold, a reminder that even the swiftest things can find stillness. Beyond the laboratory, the whispers of cold are written across the cosmos. Interstellar space, with its faint glow of microwave radiation, is a constant reminder of the universe's frozen memory. Within molecular clouds, whispers take the form of molecules combining, fragile structures forming in the shelter of chill. In the coldest corners, complex organic compounds, the precursors of life, assemble. They wait in silence, patient as the universe itself, until warmth returns and sparks new creation. The whispers at the edge of cold are not only physical phenomena, but the beginnings of stories, written quietly in frozen letters. Whispers also speak of time. The third law of thermodynamics tells us that absolute zero cannot be reached, only approached. The closer we come, the harder it becomes, like chasing a horizon that always recedes. This law itself is a whisper, a quiet reminder that perfection is not for us to hold. Stillness, like silence, is always partial, always just beyond grasp. Yet in the approach lies revelation. Each step closer reveals something new. Condensate, superfluid, superconductors, each a hidden harmony of nature. The whispers tell us that the journey matters more than the arrival, that the pursuit of stillness is more meaningful than the stillness itself. These scientific whispers also echo in our inner lives. In our busy world filled with noise and movement, it is easy to forget the value of silence. Yet when we allow ourselves to cool, to slow, to approach our own edge of stillness, we discover hidden harmonies. In meditation, in rest, in reflection, we too merge with something greater. We too find flows without resistance. The whispers at the edge of cold remind us that silence is fertile, that in quiet we hear truths too subtle for noise. The lessons of atoms are lessons for us, to slow, to listen, to allow unity to emerge. Imagine again the orchestra of atoms, and at high temperatures the orchestra plays wildly, every instrument clashing. As the temperature falls, the music softens, the instruments begin to align. At the edge of cold, the orchestra breathes as one, a single note sustained across time. This is the whisper of the edge of cold, a note so pure it almost disappears, a sound so subtle it becomes silence. To hear it is to glimpse the heart of matter, the core of existence, the quiet music that underlies everything we see. And so the whispers at the edge of cold are not faint because they are weak. They are faint because they are subtle, because they require stillness to be heard. They remind us that the most profound truths are not shouted, but whispered, not forced but revealed. In the quietest corners of the universe, matter speaks most clearly, and what it says is not chaos, but harmony. The edge of cold is the place where the universe tells its secret softly, waiting for us to listen with patience, with humility, and with wonder. Now we come to the final part of this story, where the whispers at the edge of cold gather into a soft resolution. We have heard them in the merging of atoms, in the flowing of superfluids, in the perfect currents of superconductivity. We have seen them in the laboratory and across the cosmos, written in the silence of molecular clouds and the faint glow of the microwave background. In this closing reflection, let us rest in those whispers and let them carry us toward meaning as softly as a lullaby at the end of a long day. At the edge of cold, matter ceases to behave like matter as we know it. Identity dissolves, separateness fades, and individuality blurs into unity. 1,000 atoms merge into one wave, a river flows without friction, electricity glides without loss. These are not accidents, they are revelations. They tell us that hidden beneath the noise of heat lies a deeper order, a harmony too subtle to survive in the warm chaos of daily existence. The whispers at the edge of cold are the voices of that hidden order, speaking only when the world is quiet enough to listen. These whispers also remind us of the paradox of stillness. We imagine absolute silence, absolute rest, but quantum mechanics insists there is always motion, always a hum, always a pulse beneath the quiet. The edge of cold shows us this paradox with clarity. Even in the softest silence there are whispers. Even in the deepest stillness there are rhythms. This is not failure. It is the essence of existence. A silence without whispers would be nothingness. But the universe is not nothing. It is always alive, always murmuring softly, even at the brink of absolute zero. The whispers at the edge of cold also carry memory. The cosmic microwave background is one such whisper, the faintest echo of the universe's beginning. It tells us of fire cooled into silence, of light stretched into coldness, of a cosmos that carries its first breath within its frozen heart. In this whisper we hear history itself, preserved not in books or fossils, but in the very temperature of the universe. The whispers are eternal storytellers, keeping alive the tale of beginnings long after the fire has faded. In the whispers there is also promise. The molecules formed in cold interstellar clouds are seeds of life. They drift through galaxies, waiting for warmth to awaken them. In their frozen patience, they hold the possibility of futures yet unborn. The whispers at the edge of cold are not only echoes of the past, but lullabies for the future, carrying within them the quiet seeds of creation. They teach us that silence can hold beginnings, that stillness can cradle potential, that life itself may rest in the soft arms of cold. These lessons reflect back upon us. In our lives we often chase heat, movement, urgency, activity. We fill our days with noise, our minds with constant motion. But the edge of cold teaches another way. It teaches that whispers are as important as shouts, that stillness is as powerful as motion, that unity lies in slowing down enough to listen. Just as atoms merge into harmony in the quiet of cold, so too can we find harmony in the pauses of our lives. The whispers invite us to slow, to rest, to listen to the subtler music that underlies the noise of living. As we reflect on this, imagine the edge of cold as a doorway. On one side is the noisy world of heat and chaos. On the other is the silent realm of whispers, where matter reveals its hidden truths. We cannot live in that silent realm. It is too delicate, too fleeting. But we can approach it in thought, in imagination, in the stillness of reflection. The whispers remind us that truth is not always loud, that understanding often comes in silence, and that listening is as vital as speaking. The edge of cold is not only a scientific threshold, it is a metaphor for the art of listening, for the beauty of stillness, for the depth of quiet. And so the whispers at the edge of cold are more than phenomena. They are teachings. They tell us that unity lies beneath separateness, that stillness carries rhythm, that silence holds memory and promise. They remind us that the universe is not only a blazing fear, but also a frozen lullaby. Not only chaos, but also harmony. The whispers are the universe's softest voice, heard only when the noise of heat has been stripped away. To hear them is to know that existence is layered, that beneath every roar there is a murmur, and beneath every murmur there is a whisper, waiting. Let us close gently with the image of whispers themselves. They are quiet, but they linger. They are faint, but they endure. They carry secrets, but they also carry love. The whispers at the edge of cold are like this. They are the universe leaning close, speaking softly, sharing truths too delicate for noise. And if we lean close in return, if we listen with patience and wonder, we can hear them. We can hear the unity of atoms, the memory of light, the promise of life, the poetry of silence. And in those whispers, we find not only science but comfort. For the universe, even at its coldest edge, is never silent. It always speaks softly like a lullaby at the end of time. There is a silence more profound than any forest at night, more absolute than the pause between heartbeats. It is the silence of perfect zero, the unreachable stillness of absolute zero, where motion slows toward nothingness, and the restless hum of atoms almost ceases. To imagine it is to imagine the universe holding its breath, pausing in the vastness of time. Scientists call this state 0 Kelvin, a place where temperature reaches its theoretical floor. Yet beyond the numbers, beyond the measurements, it is a silence that feels like eternity, a perfect calm at the heart of existence. Everyday warmth hides the quiet. In the rush of summer, in the glow of fire, in the touch of skin, atoms move frantically, colliding and vibrating. Temperature is nothing more than this dance of motion, a measure of the energy locked in every particle. The higher the heat, the faster the dance. But as the temperature falls, the dancers slow, their steps soften, their collisions grow rare. If we imagine lowering it further, cooling beyond ice, beyond the deep of space, we approach the silence of perfect zero. At that boundary, the dance no longer matters, for the music itself fades into stillness. This silence, however, is never absolute. Quantum mechanics insists that even at 0 Kelvin, atoms retain a faint pulse of motion, what physicists call zero-point energy. It is the smallest whisper of vibration, the residue of being itself. If silence were truly absolute, the structures of matter would collapse, and the universe would unravel. The silence of perfect zero is therefore not a void, but a limit, a horizon beyond which existence cannot go. It is a silence filled with presence, a paradox where stillness and motion meet in delicate balance. Scientists have spent decades chasing this silence, not because they expect to capture it, but because in the approach, nature reveals her most secret patterns. Using lasers, magnets, and ingenious cooling trapezoids, searchers have coaxed atoms into billionths of a degree above absolute zero. At these frozen thresholds, new states of matter bloom. Bose-Einstein condensates where atoms merge into one, superfluids that flow without resistance, superconductors that carry electricity forever without loss. Each is a fragment of the silence of perfect zero, a glimpse into the harmony that lies beneath heat and noise. To picture this silence, imagine standing on the edge of a frozen lake at night. The air is so cold that every sound seems hushed. The ice beneath your feet feels eternal, unmoving, infinite in its stillness. Yet if you listen closely, there is a faint crackle, the whisper of shifting crystals, the subtle reminder that silence is never perfect. The silence of perfect zero is like this, vast, overwhelming, filled with stillness, and yet alive with the faintest hum. It is not emptiness, but a fullness so delicate it can only be felt in the quietest of moments. The silence of perfect zero also reaches into the cosmos. Between the galaxies, in the vast dark where stars do not shine, the universe rests near 2.7 Kelvin, only a breath above the ultimate silence. This temperature comes from the afterglow of the Big Bang, stretched thin across billions of years. The cosmos, in its expansion, has cooled into silence, carrying within it the memory of fire transformed into cold. To gaze at the night sky is to gaze into this silence, to see the light of stars against a background that is almost but not quite perfect zero. And yet this silence is not barren. It is fertile, rich with possibility. In molecular clouds resting just above absolute zero, gravity gathers dust and gas until stars are born. The silence becomes the womb of brilliance, the stage on which fire can ignite again. Without the stillness, there could be no spark. Without the silence, there could be no song. The silence of perfect zero is therefore not an end, but a beginning. A reminder that quiet is not emptiness, but potential waiting to awaken. For us, this silence is also metaphor. We spend our lives surrounded by noise, of voices, of thoughts, of urgency. Yet deep within, we long for a silence that feels complete, a stillness that softens our restlessness. We seek it in meditation, in sleep, in the pauses of breath. We never reach absolute silence, just as we never reach absolute zero. But in the approach we find peace. In the nearness we hear whispers we could not hear before. The silence of perfect zero is mirrored in us, in the quiet places of our hearts where noise fades and calm begins. The silence of perfect zero is therefore both scientific and spiritual, both unreachable and present. It is the cosmic horizon of temperature and the personal horizon of peace. It is the boundary where atoms cease their frantic motion, and the boundary where our thoughts soften into stillness. It is a silence that cannot be touched, yet one that guides us, reminding us that beneath every noise, beneath every movement, there is always a deeper quiet waiting. To reflect on it is to hear the faint music of stillness, to feel the eternal calm at the heart of existence. Let us drift further into the silence of perfect zero, where the idea of stillness unfolds into deeper truths. This silence is not just a scientific boundary, but a mirror held up to existence itself. To understand it is to understand how motion and rest are woven into the same fabric, how heat and cold shape the very flow of time. In this section, we let the silence stretch wider, tracing its meaning across physics, the cosmos, and our own quiet reflections. The silence of perfect zero is the silence of atoms losing their individuality. In the warm world, every particle chatters loudly, colliding, scattering, and vibrating with constant urgency. Heat is this chatter made visible, the restless hum of matter. But as temperature falls, the chatter softens. Atoms slow their collisions, their movements become faint. Near absolute zero, the chatter almost ceases, and what remains is not noise but harmony. The silence of perfect zero is therefore not a void, but a choir made of whispers, each atom contributing to a collective calm. It is the universe showing us what lies beneath the surface noise. At this threshold, strange behaviours bloom. A Bose-Einstein condensate, for example, is not merely a collection of atoms but a merging of presence. 1,000 atoms fall into the same quantum state, behaving as though they were one. In ordinary conditions, individuality is unavoidable. Each atom moves independently, a separate self. But in the silence of perfect zero, they forget their separateness and join into unity. It is a profound lesson hidden in physics that beneath all difference lies the possibility of oneness, revealed only when the noise of heat is stripped away. The silence of perfect zero also reveals itself in the flowing of superfluids. Helium, when cooled near absolute zero, slips into this state, refusing to obey the ordinary laws of friction. It can swirl endlessly, never slowing. It can climb the walls of its container, moving with quiet grace that defies explanation in warm terms. The silence allows it to glide like a ghost, freed from the drag of the ordinary world. In this silence, matter whispers of freedom, of movement without loss, of existence without struggle. It is the closest we come to a glimpse of perfection hidden in the quiet of cold. Electricity too becomes transformed in the silence. Superconductivity is the phenomenon where electrons pair up and flow without resistance. Normally, electricity is noisy, full of collisions, wasting energy as heat. But near absolute zero, the silence brings order. The electrons stop scattering and they glide in perfect harmony. A current begun in such a state will continue forever, circling without fading. It is a current made of silence, a movement born from stillness. This is not only a triumph of physics, but a metaphor of balance. Motion that wastes nothing, born from silence that holds everything. Cosmology also belongs to this silence. The universe itself has been cooling since its fiery beginning, descending slowly toward perfect zero. The cosmic microwave background is a reminder of this journey. A faint, frozen glow spread across space. A whisper from when the universe first cooled enough for light to escape. That background rests at 2.7 Kelvin, a cosmic silence just above zero, carrying the memory of beginnings. It tells us that silence and fire are bound together, that creation always carries within it the seed of stillness, that every explosion cools, every flame fades, every voice dissolves into quiet. But the silence of perfect zero also carries a paradox. It is unreachable. The third law of thermodynamics insists that no process, no matter how clever, can cool matter completely to absolute zero. The closer we approach, the more energy it costs, the harder it becomes. It is like chasing the horizon, always visible, never attainable. This impossibility is not failure, it is protection. For if perfect zero could be reached, the universe would lose its hum, its pulse, its subtle foundation. The silence of perfect zero is not a door to be opened, but a horizon to guide us. It is a reminder that some truths are not meant to be touched, only approached. This unreachable smallness also speaks of time itself. Time is born from motion, from change. If absolute zero could be reached, if all motion ceased, time itself would lose its meaning. There would be no before, no after, only stillness. The silence of perfect zero is therefore the silence of timelessness, the imagined pause of the universe itself. To reflect on this is to realize how deeply time is tied to warmth, to difference, to motion. The silence at the end of all cooling is not only physical but temporal, the boundary where time itself fades into quiet. In human terms, the silence of perfect zero is mirrored in our longing for rest. We yearn for quiet, for stillness, for peace from the constant noise of thought and life. Yet like absolute zero, perfect silence is unreachable. Our hearts beat, our lungs breathe, our minds wander. There is always a hum, always a pulse. But just as in physics, the impossibility of perfection does not diminish the beauty of the attempt. To approach stillness is enough. To listen for whispers in the quiet is enough. The silence of perfect zero teaches us that perfection is not possession, but pursuit. So let us imagine the silence one last time. Picture a vast expanse of stars, their light fading slowly into darkness. Between them, the background glow cools further, sinking ever closer to zero. The galaxies drift apart, the stars die, the black holes evaporate. And yet, in that silence, the hum of quantum fluctuations persists, faint but eternal. The silence of perfect zero is not empty. It is full of presence, of memory, of potential. It is the deepest lullaby the universe can sing, a song of quiet so vast it holds the whole of existence within it. The silence of perfect zero is therefore not an end, but a horizon, not a void but a fullness. It is the calm beneath motion, the quiet beneath sound, the stillness beneath time. We cannot reach it, but we can let it guide us, reminding us of the value of quiet, the beauty of slowing, the power of whispers. To reflect on it is to hear the universe at its softest, to feel existence at its most patient, to know that silence itself is alive. And in that knowing, we find peace, as if the cosmos were holding us gently in its endless calm. Now let us move gently into the closing part of this story, where the silence of perfect zero gathers into its final reflection. We have seen it as a boundary of physics, a place where atoms lose their chatter and time itself seems to pause. We have watched it in the strange states of matter born from cold, and in the vast cosmos cooling slowly towards stillness. To end here is not to end in emptiness, but in calm, a quiet acceptance that perfect silence, though unreachable, is always near. The silence of perfect zero is not only about matter, it is also about meaning. Every scientific pursuit of this silence has shown us not failure but revelation. The impossibility of reaching absolute zero has led to discoveries of condensates, superfluids and superconductors. The refusal of atoms to fall completely still has revealed the necessity of zero-point energy, the hum that keeps existence alive. The silence of perfect zero hides its truths in the unreachable, showing us that the horizon itself is where wisdom lives. Sometimes the greatest gift of nature is not what can be attained, but what can only be imagined. This silence is written into the destiny of stars. White dwarfs, remnants of suns, will one day cool endlessly, approaching but never touching the perfect quiet. They will become black dwarfs, cold, dark, nearly motionless, yet never truly at zero. Their silence will echo through galaxies, the faint whisper of fire that once was. Black holes too will fade, radiating their last energy into the cosmic dark, leaving behind a silence so deep it feels eternal. And yet even then, the silence will not be perfect. Quantum fluctuations will persist, tiny ripples across the void like the faintest breath in a room thought to be still. In this way, the silence of perfect zero is not finality but continuity. It is the thread that runs beneath all things, from the fiery birth of the universe to its imagined end. It teaches us that stillness and motion are not opposites, but partner, bound together in endless play. Without sun, motion could not be heard. Without motion, silence would have no meaning. Perfect zero is the imagined balance point between the two, the symbol of their union. It reminds us that even in stillness there is movement, and even in silence there is song. This lesson stretches into our own hearts. We too long for silence, for pauses in the noise of life. Yet even in our quietest moments, we feel the pulse of blood, the flicker of thought, the hum of breath. We never reach perfect silence, nor do we need to. The pursuit is enough. Just as science learns from approaching absolute zero without ever reaching it, so do we learn from seeking peace, even if we never hold it completely. The silence of perfect zero is reflected in meditation, in sleep, in the calm moments between worries. It is a horizon we walk toward daily, finding meaning not in its possession, but in its pursuit. Imagine standing in the vastness of night, with stars above and the earth cold beneath your feet. The air is quiet, the world hushed. In that moment, you may sense a silence deeper than your ears can measure, a stillness that feels cosmic. That is the silence of perfect zero, not present in numbers but present in feeling. It is the sense that beneath every noise there is quiet, beneath every thought there is stillness, beneath every movement there is calm. It is the silence that holds us, whether we notice it or not. The silence of perfect zero is also a reminder of humility. We cannot control it, cannot grasp it, cannot arrive at it. It is beyond reach, and yet it shapes everything. The universe has been cooling toward it since the moment of the Big Bang, and it will continue cooling forever. We are but sparks in this journey, flashes of warmth against the backdrop of endless stillness. To reflect on this is to understand how fragile, how precious, our warmth truly is. It is a gift to burn, to shine, to exist, even briefly against the silence of perfect zero. And yet the silence is not an enemy to life. Without cold, stars could not form, molecules could not combine, history could not be preserved. Cold is the canvas upon which warmth paints its story. The silence of perfect zero is the purest form of this canvas, the ultimate ground on which existence rests. It is not destruction but foundation, not emptiness but potential. It is the quiet field in which the seeds of creation are planted, the deep soil of stillness from which light and life can grow. So as this story closes, let us rest in the thought that the silence of perfect zero is both unreachable and always present. It is in the faint glow of the cosmic background, in the cold air of night, in the pause between breaths. It is the horizon of temperature and the metaphor of peace. It is the reminder that beneath all heat, all sound, all motion, there lies silence, patient and enduring. We cannot hold it, but we can listen for it. We cannot arrive at it, but we can walk toward it. And in that walk, in that listening, we find meaning, calm and wonder. The silence of perfect zero is not the absence of life, but the background against which life sings. It is the stillness beneath time, the hush beneath existence. To imagine it is to imagine the universe resting, to feel eternity breathing softly, to hear the quietest of songs. And though it will always remain beyond our reach, it will always remain within our hearts, guiding us toward peace, reminding us that silence itself is alive. In the quiet imagination of science, there is a dream of atoms lying in eternal sleep. It is not a sleep of death or ending, but a deep and endless rest, where motion softens to its gentlest hum and the noise of heat no longer disturbs the stillness. This dream arises when we picture the ultimate cold, a state so near to absolute zero that matter itself seems to drift into slumber. Atoms, once frantic with movement, settle into calm patterns, almost motionless, as though they were resting after an ancient journey. This is the dream of atoms in eternal sleep, a vision where the universe itself seems to pause in quiet reverie. To understand this dream, we must remember that all warmth is motion. Every flicker of fire, every breath of wind, every beat of the heart is made from atoms trembling, colliding and vibrating. Heat is the music of existence, the endless dance of particles. But as temperature falls, the music slows, the dance softens. Atoms no longer collide with urgency, but drift like feathers settling through air. As they near absolute zero, their movement grows faint, almost imperceptible, as if they're drifting into sleep. The eternal sleep of atoms is this imagined horizon, where motion fades into whispers too soft to hear. Yet this sleep is never complete. Quantum mechanics tells us that even at absolute zero, atoms retain a faint residue of energy, a subtle quiver that cannot be erased. This is zero-point motion, the eternal hum of being. It is as if the atoms, even in their deepest rest, continue to dream, never entirely silent, never fully still. The eternal sleep of atoms is therefore not the silence of emptiness, but the silence of presence, the quiet rhythm of existence persisting even in the coldest hush. Their sleep is not an end, but a state of being so subtle it becomes almost invisible. This dreamlike state can be glimpsed in the laboratory, where scientists cool atoms to billionths of a degree above absolute zero. In these frozen conditions, atoms begin to behave as though they are dreaming together, merging into collective states that cannot be seen at higher temperatures. Bose-Einstein condensates, superfluids, and superconductors are all examples of matter drifting into this dream. In each, individuality dissolves, and the many become one. It is as if the atoms have fallen asleep side by side, breathing together, their rhythms aligned, their boundaries blurred. Their eternal sleep is a shared dream, soft and harmonious. In a Bose-Einstein condensate, for example, countless atoms lose their separateness and flow as one wave. They no longer act like a crowd of restless individuals, but like a single, unified dreamer. Their motion is no longer chaotic, but deeply coordinated, like the synchronized breaths of 1,000 sleepers in the same room. In superfluids, the dream continues as liquids flow without friction, slipping endlessly without resistance as though gliding through a landscape of sleep. In superconductors, electrons pair and drift without scattering, their current eternal, their flow perfect. Each is a glimpse of atoms drifting into the same dream, sharing a sleep that feels infinite. Beyond the laboratory, the dream of atoms in eternal sleep is written into the cosmos itself. In the vast cold between galaxies, atoms drift near absolute zero, resting in silence. The cosmic microwave background, at just 2.7 Kelvin, is the lullaby of this dream, the faint afterglow of creation stretched into frozen quiet. In distant futures, stars will fade, black dwarfs will cool, and matter will sink closer to this dreamlike state. The universe itself seems destined to drift toward eternal sleep, cooling forever, never reaching absolute stillness, but always approaching it. It is a dream that spans not moments but eternity. This dream of eternal sleep is not frightening. It is serene, filled with patience and peace. It reminds us that stillness is not death but balance, that silence is not emptiness but fullness. Atoms in eternal sleep are not gone. They are resting, humming softly with zero-point motion, carrying memory within suns. Their dream is not an absence of life, but its continuation in another form, too delicate to see with ordinary eyes. To imagine atoms in eternal sleep is to imagine existence itself resting, breathing softly, holding its secrets in quiet. For us, the dream has a mirror. We too long for rest, for moments when the noise of thought and life quiets into calm. In sleep we find restoration, and in silence we find meaning. Our own lives echo the physics of atoms. We dance in heat during our days, restless and full of energy, and then we seek the stillness of sleep, where we return to quiet and unity. The dream of atoms in eternal sleep is the universe's reflection of our own need for rest, a cosmic reminder that stillness is as essential as motion, as essential as sound. So let us hold this image gently, atoms drifting into sleep, their motion slowed to whispers, their individuality dissolved into unity. They are not lost, but dreaming. They are not silent, but humming softly in a way we can barely hear. Their eternal sleep is not emptiness, but presence. It is the dream of the cosmos itself, the endless hush at the edge of time, the quiet that underlies every movement. To imagine it is to feel peace, to know that beneath all noise and heat lies a rest so deep it feels eternal, a sleep that holds the whole universe in its embrace. Let us drift deeper into the dream of atoms in eternal sleep, where their rest becomes more than a scientific vision, but a meditation on time, memory, and harmony. The dream begins in the slowing of motion, in the cooling of matter towards stillness, but it unfolds into something larger, a reflection on how the universe itself longs for rest, how every flame eventually softens, how every voice eventually fades into quiet. The dream of eternal sleep is not an ending, but a transformation, a change from chaos into calm, from noise into whisper, from fire into peace. In this dream, atoms are no longer restless dancers but sleepers curled together. Each carries within it a trace of motion, the hum of zero-point energy, but their rest is deep and enduring. They are not gone, only quiet, as if waiting for a new story to begin. Scientists who cool atoms to the edge of absolute zero often describe their behavior in poetic terms: a merging, a unity, a soft surrender. What they see is not absence but presence in another form, matter woven into patterns of rest that do not appear in the noisy world of heat. The eternal sleep of atoms is the universe showing us that rest is as fundamental as motion. This dream reveals itself in the states of matter unique to extreme cold. A Bose-Einstein condensate, for example, is like a community of dreamers. Each atom's individuality dissolves into the collective as though they share a single dream. Their wave functions overlap, blending until they act as one being, one rhythm, one thought. It is the purest expression of unity, achievable only in the silence of near-zero temperatures. In superfluids, the dream continues. Liquids flow as though freed from weight, gliding endlessly without resistance. In superconductors, currents flow without loss, forever sustained, as if electrons have entered an eternal drift. These are not just scientific curiosities. They are glimpses of the deeper dream of matter, the vision of atoms in eternal rest. The dream stretches beyond laboratories, written into the story of stars and galaxies. White dwarfs, remnants of suns, will cool endlessly into black dwarfs, stars in deep slumber. Their light will be gone, their warmth extinguished, yet they will still persist, silent and frozen, resting in the universe's endless night. Black holes too will one day fade, radiating their last warmth until they vanish into the void. The universe itself will cool, stretching toward perfect silence, toward a horizon where all motion softens into rest. The dream of atoms in eternal sleep is not only a laboratory vision, it is the destiny of the cosmos itself. Yet in this dream there is always a hum, a flicker, a whisper. 0-point energy ensures that silence is never absolute. Even in eternal sleep, atoms continue to breathe softly, a hidden rhythm that persists through all time. This hum is the heartbeat of existence, the thread that keeps the universe alive even in its deepest quiet. The dream of atoms in eternal sleep is not emptiness but fullness, a reminder that stillness can be alive, that silence can carry presence, that sleep itself can hold a subtle pulse. This dream is also the cradle of creation. In interstellar clouds cooled to near absolute zero, atoms gather patiently, resting together in silence. Within that rest, molecules form: water, carbon, organic compounds, the seeds of life. These frozen clouds are not barren but fertile, holding the beginnings of stars and planets, the chemistry of future worlds. Out of the dream of atoms in sleep, galaxies awaken. Out of their stillness, new brilliance is born. This paradox, that stillness creates, that sleep gives birth, is the poetry of the cosmos, written in the language of cold. For us, the dream holds lessons too. We live in heat, in constant motion, in ceaseless thought. We chase energy, progress, and speed. Yet, like atoms, we also long for rest. Sleep restores us, silence renews us. Stillness heals us. The dream of atoms in eternal sleep reflects our own yearning for peace, reminding us that rest is not failure but balance. Just as atoms reveal their deepest nature in cold, we too reveal our hidden depths in stillness. In the quiet of sleep, in the pause of reflection, in the calm of breath, we find truths that noise conceals. The dream of eternal sleep also teaches patience. Atoms drift into these states only under the most delicate conditions, requiring care and time. The journey towards stillness cannot be rushed. It must be nurtured step by gentle step. Likewise, our own rest requires patience. Peace cannot be forced. Silence cannot be commanded. They arrive when we slow ourselves, when we allow space for quiet, when we surrender urgency. The dream of atoms is the dream of patience, of waiting softly for balance to emerge. Imagine the universe as a great sleeper. In its beginning, it blazed with restless energy, a fire too loud for silence. Over billions of years, it has cooled, its noise softened, its fire dimmed. One day, it will rest in silence, its atoms drifting into eternal sleep, humming faintly with 0-point energy, but otherwise calm. To picture this is not to picture death, but peace, the peace of a cosmos that has burned brightly and then chosen to rest. The dream of atoms is the dream of the universe itself, an endless sleep that holds memory, presence, and quiet together. In this way, the dream is both scientific and poetic, both physical and metaphorical. It tells us about states of matter, about the future of stars, about the hum of quantum motion, but it also tells us about ourselves, about the need for rest, the power of silence, the beauty of stillness. To imagine atoms in eternal sleep is to imagine a peace so deep it feels infinite, a quiet so full it feels alive. It is to imagine the cosmos closing its eyes, breathing softly, and dreaming forever. Now we arrive at the closing reflection of this final story, where the dream of atoms in eternal sleep gathers into a quiet conclusion. We have wandered through their slowing dances, their merging into unity, their role in the destiny of stars and galaxies. We have seen that sleep, in this cosmic sense, is not emptiness but presence, not silence but whisper, not death but transformation. In this last part, let us rest with the dream itself and hear what it tells us about the universe and about ourselves. Atoms in eternal sleep are not gone, but changed. In their deepest rest, they reveal their unity, flowing into states that transcend individuality. A Bose-Einstein condensate is not many atoms but one presence, one rhythm, one dream. A superfluid is not liquid as we know it, but motion freed from resistance, gliding endlessly like a dream that never ends. A superconductor is not electricity and struggle, but electricity perfected, flowing without loss. These states are fragments of the eternal sleep of atoms, glimpses of the quiet order that lies beneath the noisy world of heat. They remind us that beneath separateness lies unity, beneath chaos lies harmony, beneath emotion lies rest. The dream of eternal sleep also carries the memory of the cosmos. The universe has been cooling since its fiery birth, carrying the echo of beginnings in the cosmic microwave background. This faint glow, at just 2.7 Kelvin, is the lullaby of creation stretched thin across space. It is the universe whispering of its own childhood, of the fire that once blazed, of the silence that followed. In the far future, as stars fade and black dwarfs cool, the cosmos itself will sink closer to this dream. Galaxies will drift into darkness, matter will thin, and atoms will rest in a slumber that feels eternal. The dream of atoms in eternal sleep is not a fantasy, but the destiny of time itself. Yet even in this dream, the hum of 0-point energy persists. Perfect stillness is forbidden. The universe will never truly fall silent. It will always whisper, always breathe, always flicker faintly with quantum presence. This hum is the heartbeat of the eternal dream, the quiet reminder that nothing is ever truly gone. Atoms in sleep continue to exist, to hum, to carry memory. Their sleep is not absence, but the most delicate form of being. In this hum, we hear the truth that silence itself is alive, that even in eternal sleep there is presence. For us, this dream is a mirror. We too long for stillness, for rest, for peace. We live in heat and motion, in urgency and noise, but we seek sleep at the end of each day, silence at the end of each thought. Our own rest is never perfect. We dream, we breathe, our hearts beat. Yet this imperfection is beautiful, for it mirrors the imperfection of atoms, their refusal to be perfectly still. Just as they hum in eternal sleep, so do we. Just as their rest is alive with presence, so is ours. The dream of atoms in eternal sleep is also our dream, the reflection of our own need for quiet. This dream teaches us patience. The universe will not rush into silence. It will take billions upon billions of years to cool. Atoms drift into unity only under the gentlest conditions, requiring care and time. Stillness cannot be forced. It must be allowed, nurtured, surrendered to. The dream of eternal sleep reminds us that peace comes not through urgency, but through slowing, through listening, through soft acceptance. It is a lesson both scientific and human, that stillness is not absence but presence waiting quietly for us to notice. So let us picture the dream one last time. Imagine the universe as a great sleeper, lying across eternity. In its beginning it blazed like fire, restless and loud. Over ages, it cooled, its noise softened, its motion slowed. One day, it will rest in near perfect silence, atoms drifting in eternal slumber, humming softly with 0-point energy. This is not an ending, but a balance. It is the peace of a universe that has lived, burned, created, and then chosen to rest. To imagine it is to imagine calm itself, infinite and patient, holding all things in quiet embrace. And let us hold this image close. Atoms as dreamers, resting forever, humming faintly in sleep. Their dream is not empty but full, not silent but whispered, not gone but transformed. It is the dream of the cosmos itself, the endless lullaby of existence, the quiet song that carries us from beginning to end. To rest in this thought is to feel peace, to know that beneath all motion lies stillness, beneath all noise lies silence, beneath all life lies rest. The dream of atoms in eternal sleep is the dream of the universe itself, a dream that never ends, a sleep that is always alive. So the story closes, not with fire, not with noise, but with silence. Not with absence, but with presence. Not with death, but with eternal rest. The atoms dream, the universe dreams, and we dream with them, carried softly on the whispers of eternal sleep. And in that dream, there is comfort, and there is wonder, and there is peace.